Hi, Assalamualaikum warahmatullahi wabarakatuh. In the previous video, I have talked about a little bit, or I have given some sort of introduction about Poisson distribution. So you can see that its probability function is described by this right here, where you can see there's one parameter, we have lambda, and let me just tell you this, our x here, the random variable x here, can take values such as 0, 1, 2, and so on. And if you have a Poisson random variable, therefore the expected value of it is going to be lambda, and the variance of it is also going to be lambda. And in this video, what I'm going to do next is I'm going to prove that if x has a Poisson distribution, then the mean is lambda and the variance is also lambda. Okay, so that's what we're going to do in this video. And if you have done, or if you have watched the videos related to finding ex, expected value of x, and variance of x for different cases, like for binomial or for negative binomial distribution or for geometric distribution, then you will find that what I'm about to show you next will look relatively easier, because all the steps that we are going to do next are very similar to what you have seen in all those cases here. Okay, so without further ado, let's just continue with the process of finding expected value of x, and this is just the summation of x times with fx. So I'm just going to write down that first. And what is fx? Well, fx is this guy right here, so let's write it down. So we have lambda x factorial e negative lambda, and x here begins from 0 until n. Okay, so here x begins from 0 until n, and however, if you substitute 0 into x, then the whole thing here becomes 0. So we can actually start the process from x equals to 1. Okay, so that's what we're going to do. We can start the process x equals to 1. Next is we're going to try and get rid of x here. So what we can do is we can write down this bottom part here, x factorial, with something that looks like this, x minus 1 factorial. This is what you have already seen many times when I discuss finding expected value of x or variance of x for all those cases here. Okay, so this is nothing new. Next, we can cancel out x with x at the bottom. Now what we're going to do is we're going to try and match this part here with something that looks like x minus 1. Also, notice that we can do that by writing it in terms of, so we can write that in terms of lambda x minus 1 times lambda. You can see by doing this process here, it is the same thing as having lambda to the power of x. It is the same thing. Okay, now what we have to do next is just write down x minus 1 factorial e negative lambda. Now I hope you can see that lambda here doesn't depend on x, therefore we can consider taking it outside of this process. Okay, so that's what we're going to do next. So here we've got lambda, and here we have lambda x minus 1 over x minus 1 factorial e negative lambda. Okay, next what we're going to do is we're going to simplify the look of it by representing these two guys here in using just one alphabet, so you make things easier. Okay, so what we're going to do is we're going to let y becomes x minus 1. And that here becomes, so therefore I'm just going to call this 1. So therefore 1 becomes, so here we have lambda, so this one is going to be lambda to the power of y. This is y factorial e negative lambda. So right now here we're going to have y instead of x. So y is equal to x minus 1. If x is 1, you substitute that into here. So y will begin from 0. If x is n, then you substitute that into that. So that will be n minus 1. So we can just write down that equals to n really. Okay. Okay, so now what are we going to do is, I hope you can recognize that this process here, this part right here, this one, it looks similar to this one here, except that we have different alphabet. Instead of x, we have y and y factorial. So it means that our y here is a random variable, and it has a Poisson distribution, because this is the probability distribution function for a Poisson random variable. Yeah, and if you sum up all the probabilities from 0 until n, the result is supposed to be equal to 1, and therefore final result of that is going to be lambda times 1, which is just going to be equal to lambda. So that's it. Okay, so we have managed to prove that the mean of a Poisson random variable is lambda. Okay, next we're going to move on to proving the variance of x. Okay, so now let's look at variance of x. So we all know that in order to find variance of x, you need to find expected value of x squared minus ex, and you square it. And you have also seen this. It is difficult to find expected value of x squared, and so we're going to manipulate and think about it. Okay, think about finding it using a different approach, which is to find expected value of x minus 1 plus ex. Okay, and what it is really, so this guy here, the whole thing here, okay, if you expand the whole thing here, it becomes e. So you expand this term, x times x, you got x squared minus x, yeah, plus ex, the value of x, and that becomes e x squared minus ex plus ex, and so you can cancel that part. So you can see that this whole box here is the same thing as finding ex squared, which is what we need really. Okay, and I hope you know what's the reason why we have to do it this way, because by doing this we will be able to express and cancel out all the x minus 1 with the one here. We can use x factorial, we can rewrite x factorial in a way that we can cancel out x and x minus 1. We can cancel out this part. Okay, so that's the reason. If you have it with x squared, then that cannot be cancelled out, and we're going to have problem later on. Okay, right, so let's continue and do this. Here we have expected value of x minus 1, which is equal to taking the whole function here, x times x minus 1, and we're going to multiply that with our fx. Our fx is lambda x factorial e negative lambda, and x is supposed to begin from 0 until n. However, you can see if you substitute 0 into this, the whole item is going to be 0. Also, if you substitute 1 into this, so 1 minus 1 is going to be 0, so the whole thing is going to be 0. Therefore, we can say that we can begin the whole process with x equals to 2 until n. Here we've got x minus 1, lambda to the power of x. Now we're going to write x factorial in terms of x times x minus 1 times x minus 2 factorial. Okay, so I have explained about this in the previous video. So if you don't understand how this comes about, then you can refer to the proving parts related to binomial distribution or negative binomial distribution and so on. Okay. Alright, so here is e negative lambda. Now this part here can be easily cancelled out. Okay. Next, what we're going to do is we're going to focus on making sure x here has the same outlook as x minus 2. Okay, so what we're going to do next is we're going to write down the whole process as lambda x minus 2, and we need to make sure that we don't lose the original idea, which is lambda to the power of x, so therefore it has to be multiplied with lambda squared. Yeah, so here we've got x minus 2 factorial e negative lambda. So you can see that this part right here is the same thing as lambda to the power of x, so they are the same thing. Now what we can do next is, I hope you can see that lambda squared here doesn't depend on x, so we can consider taking it out of the process. Okay, so next we have lambda squared and x is equal to 2, lambda x minus 2 factorial e negative lambda. Okay, so now what we can do is we can let, okay, as always we can make sure that it looks simple. So what we can do is we can let this guy and this guy be expressed with just one alphabet. So we're going to say let y represents x minus 2. So this is equation 1. So therefore 1 becomes lambda squared, and here we have lambda to the power of y factorial e negative lambda. Right here is, we know if x is equal to 2, therefore y is going to be 2 minus 2, y will begin from 0, and if n x is n, so y is going to be n minus 2. Well, n minus 2 is some value, we can just call it n as well, so it doesn't matter. Okay, now I hope you can recognize or you remember what is this all about. This part right here is the sum of all the probabilities. So this is the probability function for Poisson random variable y. So y here is our Poisson random variable, and if you sum up all the probabilities from 0 until n, the result is supposed to be equal to 1. Okay, so what we have next is we can say this becomes lambda squared times 1, and we have managed to show just this part. We just managed to get this part right. Next, what we're going to do is we're going to calculate variance of x. So therefore variance of x is going to be this value, which this one, lambda squared, plus this guy. So what is ex? Ex is lambda, we have already shown that before, so lambda squared plus lambda, so this guy. So we are done with this part. Next, minus ex squared, so minus lambda and you square it. Obviously this can be cancelled out, and so the result is variance x is equal to lambda as well. Okay, I think that's all for now. Thank you very much for watching.